Okay, so here we are at lesson 8. Now we're going to combine some of our algebraic solving with our graphing. So we're going to take what we know from graphing and use that to solve some more complex linear equations. And then we'll look at how to solve them algebraically as well, probably in the next lesson. So we're going to solve linear systems graphically. A linear system, okay, is two or more linear equations. Okay, two or more linear equations. So the thing with linear systems is when you have more than one linear system or linear relation on a graph, they might cross over or they might not. So one of the things we're interested in is the point of intersection, which is where the linear relations cross. And when I say the linear relations cross, I mean that they have exactly the same value. Okay. They have exactly the same x and y coordinates. And you'll see that once we graph them, that the point of intersection is one point on both lines. And that's really important. Number of solutions is a really interesting idea. How many different solutions could we have? So we could have one solution, which is where the lines cross once. So we could have one solution, okay, where they cross like that. That point there is a solution. So this is one solution. Every point of intersection is also called a solution. So that's just something to keep in mind. That's a term that we use all the time. So let's think about other types of solutions. Could we have two solutions? Not if our equations are linear, because if they cross once, they're going to keep going away from each other. They're not going to bend and cross again because they're straight lines. So we can't have 2, 3, 4, 5 solutions. We can't have that. So what we're going to have is maybe 0 solutions. And 0 solutions could be like that. So what do those look like? You might recognize that they are parallel, but they're not going to cross. Ever. They never meet. And last but not least is an example where we have infinite solutions. That's the sign for infinity. So infinite solutions. And when I draw this, you might think that I'm losing my mind a little bit. There it is. Infinite solutions. I'll explain. So if I have, I'm going to put this in slope-intercept form, y equals 3x plus 1. And I have y equals 2y equals 6x plus 2. If you graph those, you will find that they're exactly the same line. So they're two different equations, but they simplify to the exact same line, which means that every point on that line is on every other line. So you get the same line, and every point is a solution, and since every point is possible on a continuous relation, you have an infinite number of solutions. Because this, if I divided everything by 2, is the same as y equals 3x plus 1. So just things to keep in mind, stuff that will definitely show up on assessments. So let's continue. Let's take a look here. Let's actually find the point of intersection. I'm going to graph both of these. I'm going to use two different colors. And you'll notice they're in slope-intercept form. So I'm going to find B1, M1 and graph it, and then B2, M2. So intercept 1, slope 1, intercept 2, slope 2. So this is equation 1. The B value is 3. That means I have a point 0, 3. So let me put that on my graph right there so you can see that. And what is my slope? My slope is 2, which is the same as 2 over 1. So it's positive, so up 2 over 1, up 2 over 1, up 2 over 1. And I can go down the other way, down to left 1, down to left 1, down to left 1, down to left 1. And I'm going to draw my line with my ruler. There we go. One done. Let's pick another color, do light blue. So this is equation 2. B value is -1, which means I have 0, -1. I'm going to put that on there as right there, 0, -1. My slope is 4, which is the same as 4 over 1. It's still positive, so my line's still going to go up. So I'm going to go up 4, 1, 2, 3, 4, and right 1. Up 1, 2, 3, 4, and right 1. Down 4. There we go. Let me draw that line. I'm sure you can already see the point of intersection, but I'm going to draw that line for you anyway. And where's the point of intersection? In red, right there, POI, and the value is, x value is 2, and the y value is 7. So I've graphed them both. I've discovered that the point of intersection is 2, 7. In order to verify that, we're going to do our first ever formal proof that we're going to do in this grade. And it is something you do need to know the structure of. It's very important. So it's called a left side, right side check. And what we're going to be doing is we're going to be confirming that the point of intersection we found, the solution to that system, is actually a point that's on both lines. How am I going to do that? Well, I'm going to test equation 1 first. So equation 1 is 2x plus 3. So y equals 2x plus 3. And we're testing the point to 7. So remembering this is x, this is y. So I'm going to split my equation down the equal sign, and I'm going to do left side, right side. So I'm going to have y and 2x plus 3. So you see I just took that and broke it apart, and I'm going to solve each side independent. Because if the solution's right, then this side has to equal this side. But I'm not going to use any rearranging. I'm only going to solve the sides as they were presented in the equation. So what's the y value? The y value is 7. I'm getting that from the POI. And the x value is 2. So this is staying 7. This is 4 plus 3. This is 7. This is 7. Now I can put my equal sign in and say as required. The left side equals the right side as required. That means that 2, 7 is definitely on the line y equals 2x plus 3. Am I done? No, because just because a point's on one of the lines doesn't mean it's on both of the lines. And to be the solution, it's the only point where both of the lines have the exact same x and y value. So I actually have to test the other equation also. What was the other equation? 4x minus 1. So y equals 4x minus 1. I'm still testing point 27. So my left side, right side is y, 4x minus 1. And then I'm going to put 7 and 2 in, replace y with the y value, x with the x value. get 7 equals 8 minus 1. 7 equals 7 as required. There's the short form. I don't know if you guys can see that. There you go. So now I've solved that. Now I have justified my point of intersection. Okay. So very important that you understand that structure and you're able to do a left side, right side check for any point of intersection that you find.